And with that, let's start with an introduction to high availability, and that is actually the first subject of our course today, and the focus of attention for our first lesson. I would like to introduce to you what high availability is actually about, and how it is distinguished from other clustering technologies. And I also want to show you the two key concepts in high availability architecture. So when we talk about clustered applications, we can talk about two very, very different things. And depending on who you talk to, people may have a completely different view of what they are talking about in terms of clustering. At the top half of your screen, you see an application which is constantly running on multiple nodes and is logically spanning those multiple nodes. This can happen in a variety of architectural details. It might be an application that happens to be multi-node aware and can basically spread out its workload over multiple nodes. This might work also in a way that the application has some means of treating those many distinct nodes, in fact, as one, and appears to be running on one node, but in fact is sharing its workload among multiple nodes. That approach is commonly referred to as high-performance clustering. High-performance clustering typically requires that the application is tailor-written to that very task. So you can't expect to just take a regular application and make it high-performance capable without a lot of programming overhead and a lot of development work that you need to put into that. Whereas if you design an application from the ground up for high-performance clustering, then that is an approach that can work very well. Typically, approaches or applications where you find high-performance clustering are things just like classic number crunching applications, cryptographic applications, mathematical simulations of nuclear explosions, you name it, climate models, and that sort of thing. So you will find that a lot in the financial sector. You will find it a lot in academia and in science. But overall, it must be said that when we talk about the deployment of clustered applications as a whole, the percentage of actual high-performance clustering applications is very, 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 very minimal, because the application requires so much tailoring to the high-performance environment, to the multi-node clustered environment, to actually deliver on its high-performance promise. Whereas, by contrast, if we are talking about another approach at clustering, we have applications that happen to be running on a single node, but which have some sort of a standby node. And this can be a very, very hot standby where the failover is practically seamless, to a warm standby, to a cold standby where you're literally powering on machines to take over the failed application. That is known as high availability clustering. Now, what's important to understand is that, of course, if you have a high availability cluster, then that does not necessarily mean that for every application you need one dedicated standby node. You can have standby nodes that are shared among applications. You can have N+1 clusters where you always have one more cluster that can one more cluster node that can take over in case one cluster node fails. But overall, it must be said that this is something that is really, really applicable to just about any application. So you can have your file services, your database server, virtualization, mail services, collaboration services, directory services, you name it. You can make all of those highly available. And as a consequence, the vast majority of clustered applications that you will find deployed in the field are, in fact, high availability cluster applications. And it's important to understand that for the purposes of this course, we are going to be talking exclusively about high availability clustering. High performance clustering is a completely different realm and has completely different goals compared to high availability clustering. What we're after is protecting our application, our services, and our data in case hardware fails. And that is exactly what HA clustering is all about. We want to minimize uptime and minimize the risk, of course, maximize uptime and minimize the risk of data corruption or data loss. The general purpose or the general concept of high availability clustering involves two key processes, and those processes are known as failover and failback. If you look at your screen now, what you see in the slide is we have a service that runs on a particular node, and at another node is available as a standby. So the other node is simply there for the purposes of taking over a resource or taking over services in case that one node fails. By the way, it says heartbeat here in the slide. That does not mean we're talking exclusively about the heartbeat cluster messaging layer. In this case, heartbeat is simply meant to be understood as a generic term where, just like a beating heart, the two cluster nodes will notify each other that they're still alive, and once that heartbeat ends on one of the nodes, so the other node uses that as a means of determining, okay, my peer node has died, I now need to take over this service, and that process is known as failover. The failover process can be automatic or manual, but in high availability clustering, we typically talk about automatic failover. So the surviving node will detect automatically that its peer node has gone away and that there are no other nodes available to service the application. And therefore, it concludes that it must now take over this application, restart that service on its own hardware, and continue to make that available. As I said, in any reasonable cluster management application, that is a completely automatic process and minimizes downtime in the face of hardware failure. The reverse process, and that is a node that has previously died, has previously gone away or forcibly left the cluster, now returns back to it, may have its service that it previously ran moved back onto it, and that process is known as failback. So failover, node goes away, the other node takes over. Failback, the previously failed node comes back, and the node that in the interim took over now relinquishes the service again. That can also be done in a manual or automatic way, but I guess it's fairly straightforward that in this case, for failback, you typically do not want to automate the process. Why is that? Well, it simply causes another service interruption. It's a service interruption that's very, very brief. It can be on the order of seconds, but it is a service interruption. And that is something that you typically don't want just because a machine that has previously failed has now come back into the cluster. What you typically want is you want to restore that machine as quickly as possible so you again regain high availability. So in case the other machine should now fail, you have something that can take over your applications and service your users. But that redundancy, that high availability that you now again have, does not mean that you immediately want to move over your service, specifically not if the service is, for example, under heavy load or you're in the middle of your peak business hours and the application absolutely has to be available. You don't want the service interruption in that case, however brief. So what you typically then want to do is, rather than having automatic failback, you want to do this failback manually during off hours, during the night, whenever your load spike has subsided, whatever it is that you want to determine as an administrator or as a decision maker or as the one who is responsible for running this infrastructure.